So in this video, we're going to talk about how do we name alkenes, and we're going to lay out the foundation, and then we're going to do some practice problems. So like with the alkanes that you guys have already learned, for alkenes, you want to identify the parent chain, right? So that is the longest continuous carbon chain, right? So identify the parent chain, which should include the alkene, right? So identify parent chain, which includes the alkene. The second thing you want to do is then identify and name the substituents. Right, so you want to identify and name the substituents. Right. The third thing you want to do is then assign a locant to each substituent. In other words, assign a number. Right. So assign a locant or a number. And the locant is just a fancy word for the number to each substituent. Right. When deciding a numbering scheme, start numbering nearest the end of the double-double bond, right? So under here, we want to say that you want to start numbering. Right, so when you're counting the carbon chain, you want to start numbering nearest to the alkene bond. End of the alkene bond or the carbon double-double bond. All right, and we're going to go through an example to kind of illustrate that point. Obviously, again, the fourth thing we want to do is list the substituents in alphabetical order. Right, so you want to list the substituents in alphabetical order. The fifth thing you want to do is identify the position of the alkene bond. And then the last thing you want to do is assign, in other words, assemble. Last thing you want to do is assemble the name, and you want to use the ending. You want to use the ending "-ine", right? So you want to use the ending "-ine", right? So remember when we talk about the alkane, we spoke about the alkanes. We said that it was heptane or hexane. The only thing we do is just replace the "-ane" with the "-ine", right? So if the carbon chain is 6 carbon long, instead of saying hexane, we say hexene, etc. So let's look at an example. How do we name this? How do we name this molecule? Well, I'm going to label carbons, right? So we label 1, 2, 3, 4, 5, 6, 7. That's my longest continuous carbon chain. So my longest continuous carbon chain in this case would be heptane, but because we're dealing with an alkene, we say it's actually heptene. Now we have to label where the double bond occurs, right? So the double bond starts at carbon 2, so we actually say this is 2 heptenes, right? So that's assigning the locant. How about the substituents? The substituents, I'm just going to write sub. We see that on carbon 5 we have a methyl group, right? So we actually have 2 methyl groups. So this is 5. So let's say this is 5-methyl. We also have another 5-methyl. And then on carbon 6 we also have another methyl. So this is 6-methyl. So the only thing we have to do now is put our stuff in alphabetical order. Now, there's not really alphabetical order here because we only have methyl groups, right? So putting the name together, we say this would be 5, 5, 6 dash trimethyl, because there we have 3 methyl groups, dash 2 dash heptene, right? So this would be the IUPAC name for this molecule. Now, what you do not want to do, and we spoke about the example above with respect to naming the alkene. What you do not, this labeling is incorrect. So if you label this as carbon 1, 2, 3, 4, 5, 6, 7, that is incorrect because we're not giving the alkene the lowest number possible. So in this scenario, the alkene would get carbon, it would be 5-heptene instead of 2-heptene. So that's what we mean by numbering nearest to the end of the carbon-carbon double bond, right? So the closest, the lower the number you can give the carbon-carbon double bond, that would be the name, right? So this labeling is incorrect. Let's look at another example. How would we name this molecule? Well, how would we name it? Well, the first thing I'm going to do is number the carbon chain. Right? Now, I'm going to start from here. Let me use a different color. So this would be carbon 1, 2, 3, 4, 5, 6, 7. Right? So we know that this is heptene, and in other words, this is 3-heptene. That is the parent chain. Right? So we locate the parent, which is heptene, and the double bond starts at carbon 3. Now we have a plethora of substituents, right? So if I write just sub, you can actually see that on carbon 2, we actually have 2 methyl groups. So on carbon 2, we actually have 2 methyl groups. So this would be 2-methyl. We also have 2-methyl. On carbon 4, we also have a methyl group. So this is 4-methyl. On carbon 5, we have a bromo group. So this is 5-bromo. And we said that we have our 3-heptene. So if we put our name together, remember now we have to use alphabetical order. So this becomes 5-bromo dash 2,2,4 dash trimethyl, because we have 3 methyl groups, so we have to put our prefix tri, dash trimethyl dash 3-heptene. Now again, if I draw the structure again like this, and here's my bromine, I cannot label from this end, right? So if I label this as 1, 2, 3, 4, 5, 6, 7, this would be incorrect because now I'm given the alkene number 4. So this would be 4-heptene instead of 3-heptene. And so we want to give the alkene the lowest number possible. So again, that's why we labeled this way initially. So again, be very careful. Let's look at this last example. How will we name this molecule? Well, again, the first thing I'm going to do is find the parent. Now notice that we have 2 alkenes in this molecule. But again, it doesn't matter. We want to give the alkenes the lowest number possible. So I could start from the left side or the right side. I'm going to start from the right side because it gives my alkene the lowest number possible. And so this is 1, 2, 3, 4, 5, 6. So now we're dealing with an hex. We're dealing with an hexene. Now, there's a trick, all right? So there's a trick here. Because we're dealing with 2 alkenes, we have to put our prefix. So it's not now hexene, it is hexadiene, right? Or we could have hexatriene if there was 3 alkenes. or if it was seven, if it was a 7 carbon chain like heptene, we would say this is heptatriene if it was if it was three alkenes, or heptadiene, etc. So you get the kind of gist here, right? So essentially we have a hexadiene as the parent in this case, because we're dealing with two alkenes, a 6 carbon chain. Now we have to give the alkene their locant position. So we have an alkene at position carbon number 1, and we also have an alkene at position carbon number 3. Right, so that's our parent. For substituents, if I'm just going to write at sub, what do we have? We have on carbon 4, we have a bromo group, so this would be 4-bromo. And carbon 1, I'm sorry, on carbon 2, we have a methyl group, so this is 2-methyl. And carbon 3, we also have a methyl group, so this is 3-methyl. So those are all our substituents. So let's put the name together. Now, I want you guys to remember this. The previous examples that we did above, well, first of all, they did not have two alkenes, but that's not the point. The point here is that they did not, on either side of the alkene, there were hydrogens. In other words, if I split the alkene here in half, I could see that I have a hydrogen here. Anytime you have non-hydrogen groups on both sides of an alkene, you have to give that the trans-cis configuration. So here we have to use our trans or cis nomenclature, right? So if you look at the alkene in this molecule, on either side, we do not have a hydrogen group, right? So anytime you have non-hydrogen groups on either side of an alkene, you have to give you have to use a trans-cis nomenclature. Now, in this case, we have a bromine group on the left side and a methyl group on the right side. Now, these groups are opposite each other, so we say that this would be a trans configuration, right? The two groups, or the two highest groups, are opposite each other, and so we say that this would be a trans configuration. So how do we name this? We say this is trans in alphabetical order. So this would be 4-bromo dash, we use our methyl now, so this is 2,3 dash dimethyl, because we have two methyl groups, dimethyl dash 1,3 dash hexadiene. Ladies and gentlemen, this is how we label or name our alkenes with respect to their nomenclature.